an example of some Angular code, right? So here we're instantiating an Angular module called things, and we're calling a controller, and we're giving it this name. We're making it minification safe by saying, hey, when I pass in $scope and my service, I mean $scope and my service. So when this becomes A and that becomes B, everything's cool, right? So then I'm using this magical variable here called $scope, and I'm attaching a value to it. I'm attaching an empty string for that, and then I'm doing a service call, and then I'm using Angular's magical promises, and I'm unwrapping this magical value in here, and everybody understands that, right? It's almost entirely framework code. That makes me sad. Like, there's almost no, there are very few things in there that are strictly JavaScript, right? None of it's native. And here's the worst, the pièce de la résistance of things that I hate doing. Debugging unhelpful errors. This is an actual error message that actually happens in the console. If I think about it, I'll tweet the link to where this came from. But here's the important part. Argument fn is not a function, got object, right? If you look at all this is all like the Angular source code. None of that's going to be helpful to you, right? So, obviously there's a helpful link there, right? So if you click that link, have any of you developed in Angular before? Sometimes when you have an error, there's a link and you can click it and it can be helpful, right? So there's this helpful link. So let's click it. Nope, not helpful at all, right? So these are the sorts of things that we want to get away from, right? So React. React is a Vue framework created by Facebook. Now it's important to note that a lot of people would say that comparing React to Angular is not quite an apples to apples comparison, because Angular is a model view whatever framework, so model view controller, if that's how you choose to do it, model view, view model, whatever. It handles the service layers, the API stuff. It's got a full stack of stuff. React is just a Vue framework, right? But it's really good at being a Vue framework, as we'll see. It was designed as a tool to facilitate rapid development and deliver a high level of performance. Without getting into too much into the close to the metal way that React works, it maintains a it's called like the virtual DOM, right? That's what they call it. And it is a JavaScript representation of the document object model. Interacting with the DOM, which is what web pages are based on, right? It's the way that JavaScript has access to the HTML in the rendering engine and such. Accessing the DOM directly can be really expensive, so React has an object representation of what should be rendered, and then it only does the minimal amount of changes to the DOM possible so that it can stay fast. So what would any introduction be without hello world, right? So here we have a very small little React component, right? So we're registering a new React component via react.create class, and we're passing in an object, and that object has a render function. And so inside that render function, we're returning, hey, that's not JavaScript. What is this nonsense? It's JSX. It's pretty great. So let's meet JSX first. So JSX is a JS syntax extension, JavaScript syntax extension, JSX, that looks a lot like HTML. So like if we look over here, this looks quite a bit like HTML, right? There's a few minor differences. For example, it's class name instead of class. And there are some other little quirks like that are slightly different, but if you can understand HTML, you can totally understand JSX. It isn't really JavaScript though. Browsers don't support it natively. So if you're going to use it in a production application, you're going to want to run it through a preprocessor. But there's tons of great tools for doing that out there. That's outside the scope of this talk, but a Google search will get you there. Anyway, so when you run this through the compiler, this, which is totally easy to read and figure out, gets compiled down into this, and this is the JavaScript that's actually going to be served. And so actually, when we look at this, it makes sense why this would be class name and not class, because class is a reserved word in JavaScript, right? So That's why they call it class name. And I suspect that the other minor differences are probably for similar reasons. But markup in my JavaScript, isn't that the opposite of separation of concerns? Has anybody heard of separation of concerns before? For those who haven't, separation of concerns states that, let's say you have 3 things that you need to do. You need to go off to API endpoint 1 and fetch some data. You need to go off to API endpoint 2 and fetch some data, and you munge them together and display it, right? So the separation of concerns says that that should be 3 separate components, right? Because what if you need to fetch API data A from some other place that isn't the place that you're rendering it in this particular instance, right? So that's separation of concerns. But consider this, right? So this is some Angular code again. Here we're saying, hey, this needs to be controlled. This piece of this is all an HTML file, by the way. I've got a controller called SomeController, and then I want to iterate through an array called things and refer to each single thing in that list of things, right? And then I want an H2 with the title of that thing, and I want it to be uppercase. And then I want an H3 with the subtitle, and I want it to be uppercase, right? Isn't that having JavaScript in your HTML? So is there really any difference between having JavaScript in your markup and having markup in your JavaScript? I don't think there is really. And frankly, React acknowledges that the view model and the template are tightly coupled, and it embraces it. So a component that you want to show on a page is going to have a template, and it's probably going to have at least some small amount of code logic that it needs to do, right? React acknowledges that those are 2 pieces of the same thing, right? So this gives us cohesion, right? So right here we have everything about this component in one place, including the template. It makes it really easy to find the relevant details about a given component. There's only one place to look. This encourages more fine-grained detail in how we separate out our components. So for example, that last point, imagine that you have like a template that is like 300 lines long, right? You're using Bootstrap, for example, right? Bootstrap can be very verbose. So you have a template that's 300 lines long, right? The first time you try to find something in there, you're going to realize, well, this is terrible. Why would I ever want to look through 300 lines of markup for anything? What you can do is you can split out more components. So by having your component's logic and its template together, it kind of twists your arm a little bit and makes you want to make things more granular. So the example that we're going to be talking about today, it's Hello React, right? So here is all the code for that. So we've got a function called do something, and it just alerts you got it, boss. And then the render function, we've got our Jumbotron there. And then we have a button that you can click, right? Cool. That's very cool. But suddenly we need another button. Oh no, that's no fun. So here we have it again, and this is what it would look like with 2 buttons. And of course, what we can do is we can copy and paste the code from this button, right? And paste it again, and so now we have 2 buttons. We got this button and that button.
But you don't like to copy and paste.
Right. Exactly. We don't want to copy and paste. What we need to do is we need to write a composable component. So same idea, but over here, what we've done is we've made a new, and this is actually using the class, a variant on how you can register components in like an ES6 style, or ECMAScript 2015, if that's how you prefer, right? So we're making a new component called Fancy Button. And Fancy Button, it abstracts some of this stuff out. And we'll go through a little bit more what's going on there. And then what we can do is we can say, hey, I want 2 fancy buttons. So instead of having all of this copied and pasted, you just say, I need 2 instances of a fancy button, right? So this implicitly gives you all of that complexity without having to think about it or clutter up your boss. So this .profs.button and this .profs.click handler, right? So the way React passes data is through props. And in fact, what are props? Props are the properties you pass into a component. There's two main ways that I know of anyway to do it. So in your consumer, you can your component consumer, as it were, the thing that is going to be using your fancy new component that you've written, right? In your consumer, you can pass constant values in, like strings and such, similar to the way you do with HTML attributes. So my component will have like a props.data, which will be the string a value, right? Alternately, you can do it this way. This is for dynamic values. So this is like evaluated JavaScript, right? So in this case, the parent component .sumData function is going to be called, and the return value of that is going to be set in the props of the child. And in your component, you can access your props via this.props, and then that gives you all the different props. So in this case, it's this.props.data would be that. Or if you had a value called kittens, you'd be this.props.kittens, whatever. So let's remember our pain points that we described earlier, right? Duplicating code, writing framework-specific code, and debugging unhelpful errors. Well, we already saw how we can keep our code duplication to a minimum by extracting out components. Let's have a look at the other 2 points, right? Writing JavaScript with a pinch of React versus writing Angular with a pinch of JavaScript, right? React's small API surface means more raw JavaScript and less React-specific code. Here we're using a native JavaScript array method to render multiple instances of a component instead of having some magical ng repeat that does God knows what behind the scenes, right? We're using array.map, and we're just instantiating a new thing, passing in our little indices and such, right? The key prop that is right here, it's actually, it's how React keeps track of the element that we're iterating over, and it uses that for doing its optimization. And in fact, if you do a loop-based rendering like this and don't include a key attribute, React will yell at you. So the result is that we now have button 3 and button 4 because we are looping over an array containing the numbers 3 and 4. Also, React gives you useful error messages. There are many different useful error messages that it will give you. But let's say that we forget to import fancy button. We don't have a reference to fancy button. Some frameworks would fail silently. Angular, if you try to use an Angular directive and Angular doesn't know about it, it just doesn't render that element, right? And that's really frustrating because how do I know? Nobody knows. How do you know? However, React will be helpful and say fancy button is not defined. Not only that, even without source maps and other luxuries, it's not that hard to find the offending code when this happens. This, I recreated it here, but this is what my my browser console looked like whenever I clicked on those 3 dots there. So it gave me this output, and it was like, hey, here's your problem there, guy. So that's a lot more useful than fn is not a function got object, right? React was designed to make web development faster and easier to do. Helpful errors definitely contribute to this. Are there any questions so far? Nobody?
We had one question on Twitter.
Okay.
Not to be one of those people, but isn't React technically a library rather than a framework?
Yes. It is definitely a library rather than a framework. Well job, Twitter person. I don't know. It is considered kind of both.
Where's the divide there? I feel like that's a
Exactly.
divide.
It's kind of a. It could go both ways, I guess. So if there aren't any more questions, let's.
Hold on. Before we go into Redux, which is the answer to the question that I'm going to ask,
Okay.
or one of the answers. One of the complications, you're saying it makes web development faster and easier to do.
Mm-hmm.
and I agree with that, and in lots and lots of ways. One of the pain points with it is knowing how to put all the important GUI bits at the top and pass them down to the children.
Right.
Which when you're building something that's 2 or 3 components deep is not hard. But when you've included the React router and you're like got a page and that's got some components and then that thing's got some components and you're like, I just want to throw a little toaster error message up on the page. Like, it is difficult to know what to chain down and how to do it.
Right.
Do you have any recommendations for that problem?
I do, in fact, have a recommendation. Is the second part of this talk. Actually, there are several ways to do it. And we'll cover this a little bit more when we go through the description of like the introduction to Redux. But React's data flows downward, right? So if you think of it as like an upside down tree, right? You've got your root of your page, and then from that you have some elements, some components, and then those components may have subcomponents, and it branches out, right? So if you actually utilize that to your advantage and never try and send data back up the tree, if you just send it all the way to the top and let the top handle getting it filtered back down to where you need it, it simplifies that problem quite a lot. And that's actually kind of sort of what Redux does in a way. It's one approach to it.
So if I didn't know Redux was coming, I would say the problem with that, and I guess I haven't worked beyond much of a Hello World with React, but the problem with that is your bottom components aren't really supposed to know anything about the top.
Right.
Right. So if you're saying send it back to the top, now I feel like
No, hold on. The top pushes down a function, and the bottom uses that function.
Right.
So the bottom cannot be instantiated without knowing how to handle itself.
I see. Okay.
Exactly.
So if it so it doesn't even really know it's sending it to the top. It just knows.
It just knows, hey, like let's say you've got a button. It knows, hey, I'm a button. When I get clicked, somebody, the person that made me should tell me what I should do when I get clicked.
And I don't care if that came from right above me or 8 steps above me.
Or if it got passed down through the ages from Nostradamus or whatever.
So this is dependency injection.
Kind of, sort of, yeah. It's a little bit more direct than the way things like Angular does it, or for any Java people, like Spring, it does a dependency injection. This is kind of like a direct dependency injection. I will give you your dependencies when I create you, instead of you telling it what the dependencies should be, and at some point the framework does it for you. Like
the child's not saying, I need this. The parent's saying, here you go. You got this.
Okay.
Although when you write components, you can define expected prop types and throw an error if you try to not give it all the stuff that it needs to have.
So that the error shows up
Yeah.
at the point of instantiation.
So you can create a contract basically that says, hey, you can't make a thing button unless you give it a thing handler, right?
Okay.
So Redux, great segue, audience. Redux is a predictable state container for JavaScript apps. I copied and pasted that straight off of the Redux site, so I know it's the party line, right? Because state is deterministic, big word, we'll come back to it, we can do really cool things like rewind the application. And by the time I finished making the slide deck, I forgot that I put that line in there. But I will tweet out a link and or post it in Slack. There's a great video by the guy that made this, Dan Abramov. In fact, it's this video. Redux was written by Dan Abramov for a conference talk called Hot Reloading with Time Travel, in which he demonstrated time travel debugging, which is one of the coolest things I have ever seen done. You have to watch the video. I'll be sure to give you guys the link. But basically what he does is he's got a running application, right? And it's running with Webpack, which can do hot reloading, right? So he's got a running application and he's able to hot swap in code and see it update immediately, right? And he's also able to, he wrote a little widget that he's able to take the state of his application, which is stored in a Redux store, and go backwards through it. So unclick that button, undo that jump if it's a game or something, for example. He's able to go backwards in time or forwards in time. And in more recent versions of the tool that he was using, that was like the first blush. He wasn't actually even done with Redux at the time. You can actually dump out the application state and play it back from the beginning some other time. So imagine if you like work for a company where you have an application that uses Redux, if the user encounters an exception, dump out the state, send it off to like Raygun or something, and you could replay their state on your machine and see exactly what they saw and see what steps got them to that weird place that they're at. Because I don't know about you guys, but if you've ever had to do any debugging, like weird edge cases where how did the user even get to this point? Redux can help with that. But first, before we go into Redux, we have to talk about pure functions because they're going to be really important, right? Oh, my ordering is off. Awesome. May as well do this. Just have the whole thing at once. A pure function is a function that if you give it the same input, it will give you the same output every single time. So for example, 1 + 1 is always going to give you 2, unless it's a 3-year-old and they don't know math, right? Similarly, this is going to do the same thing. If you pass 1 and 1, it's always going to give you 2. This is a pure function. Using pure functions to manage our state, like we are about to see how to do, it makes our application deterministic. So if we take the same steps, the application will be in the exact same state every time we take those steps from a known point. So like, refreshing the app, right? So something else that's going to be important to understand is what reducers are, right? To reduce in a functional programming sense is to apply a function to a set of values and pass along a value as you go, right? So in this example, we've got an array containing 0, 1, 2, 3, 4, and 5. And we have a reducer, which takes total and next, and it returns total plus next, right? So then we call a.reduce, and we pass in the reducer, right? Notice that reducer is a pure function. There's nothing, it doesn't know about anything other than its arguments that it was given, right? So what this is going to do is it's going to do 0 + 1, and then that equals 1. So it's going to go 1 + 2, and that's going to equal 3, right? So then the next time it's going to do 3 + 3, because we got 3 total so far. And then it's going to add 4 to the total of all those, and it's going to add 5 to the total of all those, and so on. Anybody off the top of your head know what the answer to this is?
15.
Correct. It is 15. Now, here you'll notice that we also, reduce also accepts the second argument. This isn't important to Redux at all, but I think it's an interesting tidbit that you should probably know. The reduce function is amazing when you can figure out a good time to use it. You can give it an initial value. And in fact, under the covers, Redux does do something like that. It's interesting to note that Redux is a really, really popular JavaScript library for using React. I think of all the Flux things, it won that battle, that war, I think, didn't it? And if I'm not mistaken, the core of Redux is what, like 70 lines? 50 lines?
Yeah, if you take out all the comments.
If you take out all the comments, it's like 10 lines good. It's so small. So reducers. To get started with Redux, you need a reducer function. And what a reducer function is a function which takes a state object and an action, and it returns a new state object, okay? So here we have a reducer, right? So it takes a state and an action. It's important to note that you must always return a state even if you weren't given one. This is going to be the initial state. So here, if state is undefined, meaning this is probably the first time this reducer has been run, we're going to return the initial state of 0. We want to just start by default with 0, right? And then actions have a type attribute so that you can update the state appropriately. So right here, we're saying, hey, if the action type is increment, I want to return state +1, or if it's decrement, I want to return state -1. And if it's none of those things, I want to return the same state that I got, right? So if it's none of those things, maybe it's an action designed for another reducer, right? Because reducers are composable. So now that we have a reducer function, I forgot to change the title on that, awesome. We can create our first store. And it's super easy to do. I said react.createStore, but it's actually redux.createStore. You pass in your reducer, and that's all it takes to start using the store. We just dispatch it into that. Store.dispatch, we say type equals increment, and what that's going to do is it's going to pass it through that reducer, and it's going to take whatever the current value of state is and return state plus 1, and that's the new state. Question so far? You look like you had one.
Yeah, that's cool.
Okay.
So in this case, the entire state is simply an integer.
Yes.
Or it's either undefined
Or an integer. Yeah. At this moment in
Right.
time,
Yeah.
the entire application state is one integer. So the store is then going to pass the current state and the action into the reducer and replace the current state with the new one. So consuming state updates, this is the exciting part and why it plays really well with React. Having a central location for all of our application state wouldn't be very useful at all if we weren't going to use the data that we're putting into it. So to access it, all we have to do is say store.getState. Boom, you've got the whole world's worth of information right there. Or if we want to always be notified when the state changes, we can subscribe to the store. So here we're making a handler function, and it's just going to console.log out the state, right? And we call store.subscribe, and we pass a handler, and that's it. Anytime a action gets dispatched through the state, or through the store, it's going to notify anything that's subscribed to it. It's going to call, and it's not going to actually notify the thing that is subscribed to it. It's going to call that function. So it's a callback, basically.
What's the filtering options for that? Because I imagine that with a relatively large data store, I mean, I would have 15 different subscribes for 15 different things that I cared about, but each of them are always going to get called and they filter within the handler function.
Well, one thing that you can do, and I think this might even be the recommended way to do it, is you can subscribe at the top level of your application and notify the whole application when the state changes, and then pass the props down through. And if we, and let's step back for a second, because I think this can be really useful to note. You don't ever mutate the state that you're given because it's a pure function, right? You always return a new state entirely. So if state in this case, instead of being an integer, was actually an object, right? You don't modify that object and then return it back out. You create an entirely new object. And one of the reasons why you do that is because React is looking for data to change, not attributes of data, but the actual piece of the prop itself, right? And that's going to say, oh, this is dirty, I need to check it, right? So in your case, right, if you've got a big old tree of state, you pass the whole blob down to everything that cares about it. You know, you pass this piece over here, and you that piece over there, and only the things that have updated will actually get changed, will be scheduled to change, right? Stop me if I say something dumb, please. He writes React code all the time. But yeah, so that's why in case that the action that is passed in isn't relevant to this kind of, to this particular reducer, we're just gonna return the same thing that we got back in. Mm-hmm. So if I didn't update, don't make a new one, just pass out the same one. And then that way you're not gonna trigger false positives and such. Does that make sense? So that's basically Redux. It's very simple. It's not complicated at all. So tying it all together, in React, data flows down the tree of components through the props. In Redux, application state is stored as a nested object tree, right? So as you might expect, this means they work really well together. Going back to our example, to add state to our application, we subscribe to the store and invoke render. So in this case, we've got a function that we're calling render, and that's where we're hooking the initial render. Like, this is the root of our application, and we're saying state is store.getState. So, bam. That should be pretend like there's parentheses there. And then we render it, and then we say, hey, store, I'm going to subscribe to the render function. So anytime data passes through the store, it's going to call render. And because React is smart, if no rendering actually needs to be done, it's just going to be like, okay, cool. Thanks, bro. Then we have access to our store throughout our app, so long as we pass it down the chain via props. And you don't have to pass the entire state of the whole world down to everything, every component. You can, like, if you've got, let's say you have like a user list as part of your page, and then you have like your navigation as another part of your page, you don't have to pass all of the state that's in the user list to the navigation and vice versa, unless that might be relevant for some reason. Your components only have to know what they need, basically.
But they have to be able to dispatch us.
They don't have to.
Okay, so if something needs to dispatch an action on the store, it needs access to the store to dispatch that action.
Or you can give it a function, you can pass a function down that will dispatch that action for them, which is, I think, the recommended way.
Which is the recommended way, right?
Yeah.
But that still has to be, that function has to be created
Yes.
at a high enough level to have direct access to the store to then.
And there's actually some other great libraries that tie into Redux that make it easier to do these sorts of things.
Yeah.
Like Redux is just like, it's a tiny thing, just the core, but the Redux has an ecosystem of its own almost in a lot of ways. There are lots of different opinions and takes on, the right ways to use it, right? It's important that it's a one-way street, right? Our data flows downhill only. If a component wants to update the state, it needs to dispatch an action, which will then propagate throughout the application. It dispatches the action to the store, usually by a function, as we mentioned. And then the store notifies the application, and the application, or your root component, and the root component propagates that down to the children. So for example, let's say that this guy knows about the store for some reason. And it's a super simple example. So we're gonna say, when you click this button, dispatch an increment action. So this is the uptick button, for example, right? When the event's dispatched, the store will pass the action to the reducer, and when the new state is returned, the render method will be called, updating any parts of your DOM that need to be updated. So React and Redux are both fantastic libraries, and each one does its job exceptionally well. They promote composition and use of native JavaScript, two things which I'm very happy about. I've actually heard it said from many different sources that if you use React on a regular basis, you will actually learn JavaScript better, because React by itself doesn't have a whole lot of special stuff as far as like syntax and things that you need to learn. In React, you're writing a whole bunch of vanilla JavaScript and touching the API very little. Most importantly, they're fun to use. Thank you.
So if we have any questions,
Yes.
Craig, could you repeat the question?
Absolutely. I'm sorry. I forgot to be doing that.
Do you have recommendations for libraries that kind of go in the ecosystem? I think the biggest challenge I've had is trying to figure out, because each piece is so small, and it seems like you have 4 or 5 libraries for each thing that you might want to do, and they'll do it a little bit differently. Is there a package, not really like a JavaScript package, but is there like a group of libraries that you kind of always use together that you've come to like, that does most of the real world stuff that you need, the heavy lifting?
That's a dangerous question to answer, because the things that work for me may not work for you. I will say that there's a library called Redux Thunk, which is really cool. It's very difficult to explain for me anyway, but it's really helpful. Let's see, can you think of any like must-haves? Thunk is definitely one.
Yeah, the React.
The question, by the way, was, do I have any recommendations? There's a huge ecosystem of Redux add-ons, and which, if any of them, are like must-haves. Like, which would I recommend?
Or React libraries.
Or React plugins as well.
Mostly use like Webpack and Babel and
Right.
that kind of stuff.
Having a good pipeline is really useful.
Investing in tooling, yeah.
Yeah, like tooling is kind of the new barrier of entry to getting started with a new web project. It used to be you fire up your browser, you write script.js, and you're good. But now you're compiling your code, and you have many files that need to be concatenated and pulled in, and you want your HTML to automatically be, this, that, and the other, right? So.
And it's one of those things that can become spaghetti. In fact, a friend of mine recently came over trying to help figure out the build system that 3 or 4 developers had written on for the last like 5 years. And in the end, I was like, look, you just need to rebuild your tooling because this person did it this way, that person did it that way, that person did it that way, and it's hobbling along, but not really functional anymore. Yeah.
So one thing that I personally recommend when I'm working with React and just in general, when I'm starting any kind of new web project, is I use Webpack. Webpack has several awesome features. It integrates with Babel, which is a transpiler. So you can use ES6 or ES 2015, some ES7 features. You can use it does there's a plugin for the JSX transformation to get everything back, and it does source mapping, and there's a a Webpack dev server that you can run that doesn't actually write out physical files for you. It just keeps it in memory, and you can have it served directly in memory. So when you update it, it doesn't even have to thrash your file system or anything. You can also if you have the correct plugins enabled, you can do hot reloading. So how many of you are familiar with the save the JavaScript file, click over, Alt-Tab to the browser, hit F5, right? With Webpack, you don't have to do that. There's a couple different ways, actually. You can do live reload, which will refresh automatically for you. So you can have your page open in another window, like on your second monitor, and just glance over at it when you make a change. It's especially useful when you're tweaking CSS. So my CSS workflow before Webpack was get the CSS the way I want it in the Chrome CSS editor that's in the browser, and then copy and paste it into the actual CSS file. But yeah, I don't do that anymore because I can just hot reload the CSS in. There's a huge movement of people that are actually bringing their CSS in with their JavaScript bundle too. And there are also people that are doing inline styles. Like doing inline styles is really popular with Webpack, or not Webpack, React, in the React community. So.
I feel like the React Redux ecosystem is a lot like Vim in that you can start off with this giant bundle of plugins, and that does all these whiz-bang things, but you're not going to understand most of what it does, and it's going to be different for every person. So you're better off starting with just like the vanilla basics. You can learn the basic React and Redux in like a day, just doing some demo stuff. And then like as you run into a problem, you can Google all that, and then you can add another library and build up your own sort of like bundle of plugins or whatever. So.
Yeah. I specifically didn't include links to a couple of React starter projects, because both of those have tons of configuration and tons of code that already exists. And it's kind of like, this is the jumping off point that I want to start at, so I'm gonna make it available for everybody. And that's great if you already understand what that code does. but I'm a Vimmer. Like I use Vim. I live by one important rule with Vim, or I've moved to Spacemacs, which is basically Vim, but Emacs, right? And that is, don't put anything in your vimrc file until you understand what it does first. Don't put anything inside your project that you're working on. Don't paste in code unless you understand what that code does. There's a couple of reasons. One, you don't want to paste in some random code and you don't understand it, because it might cause a bug and you won't know how to fix that bug. But more importantly, if it's code that you don't understand, if you make yourself have to understand it, if you have to learn enough to understand that before you use it, then that's going to give you the incentive to improve yourself.
What's the testing ecosystem like in React and Redux?
Well, one of the really cool things about both of those is that you don't actually have, like, so for example, with Angular, if you want to test Angular, you have to fake the DOM, right? You don't have to use Selenium, but you have to trick Angular, and you have to use Angular's mock library into thinking that it's doing everything that Angular normally does. And the problem with that is that Angular does like so much stuff behind the scenes, and in order to write tests for Angular, you have to understand what all of those things are that it's doing. React and Redux are both like pretty simple comparatively. They're just JavaScript, right? So a React component is just a thing, right? It's just a component, and you can, like, it's a JavaScript object, and you can run the methods on that JavaScript object and make sure that everything was called that you expect it to be. And
you know, pass in a state, call render, and test the output for a unit tested component. Okay.
Redux is even easier because everything's a pure function, guaranteed. And since everything is a pure function, when I give you this state and I give you this action, you will always give me the same result. So the testing story for Redux especially is stellar. And in fact, I think it's more important that Redux, being the data layer, right, or the model layer. I'm, like I said before, I'm an Angular developer, and I test my services and my models a lot more strenuously than I test my controllers, because mostly what my controllers are doing is hooking up, hey, you click this button to send off a request to that store, right? It's just glue code. The controller's glue. So in Redux, a lot of your guts are going on inside your reducers, and thankfully they're dead simple to test.
I do split my logic between, like, I guess the reducers, talking about Redux, like the performance of Redux. Like I do split my logic between like the reducers and the action creations.
Like action generators, or
yeah,
action creators.
right. Like where should the logic go?
Where should the logic go?
Yeah.
Well, at the end of the day, you can put some processing in your action creator. So for example, you want to send off a message, right? And maybe that message is coming from a form, and you want to kind of massage the data from that form before you send it off to the store. You could either put all of that in the reducer and just expect it to be not in the form that you want to store it in your store, or you can massage it before you dispatch the action that you're generating. So it's kind of up to you, really. I think it makes the most sense to massage, like have the reducer be in charge of the data and what's happening to it. You should tell the reducer what you want to do, and the reducer should be the one that makes the decisions as to what actually gets done. That's my opinion. Anyway, there's more than one way to skin a cat, right? Whichever way you choose, be consistent.
So if you have a button component,
Okay.
you've got a click handler,
Okay.
and you want to call some other function inside of that same button component.
Mhm.
you have to, like, this gets lost. Like by default, if you just do this dot like click or whatever.
Right.
So I've seen a couple of different ways of how you bind that. Like you can do this dot click dot bind, or you can do like an arrow function.
Right.
Or
I usually go the arrow function route. So let's see, let me find the slide where I did it and I'll show you the way I prefer to do it. So if we look over here, the way I did it was I've got an arrow function. So what I'm saying is on click, I'm making an anonymous function that says this.props.clickhandler, right? So I'm not binding this.props.clickhandler to this onClick event because that's going to get lost. Instead, I'm using an arrow function because the function is being created inside the scope in which this is actually the component. Yay, JavaScript, lexical scoping.
Yeah.
This, never confusing, right? Always confusing.
I was reading the docs yesterday, and it said something about rebinding them in the constructor. So you do this dot click equals this dot click dot bind this in the constructor.
Sure.
So then you're not doing it every single line or something.
I don't think that example has nearly enough this in it. Like,
it's kind of awful.
if you don't say this at least 10 times, then you're doing it wrong. You need to be more ambitious.
I have found that when passing down a function, I almost always find this function if I'm passing the function.
Yeah.
So that I have access to the props of the parent.
Although, if your children need access to the props of the parent, then those should probably be passed down as props rather than. Oh, you mean in the function that's being passed down?
When passing down
Gotcha.
the function, I want to take action at the parent level.
Right. You want the function to take action at the parent level.
Okay.
Right.
Correct.
Yeah. Got it. I get it. Anybody else?
When are we switching over all our stuff at work to this?
Tomorrow.
Ooh, actually, I got another thing to bring up to recommend this to people. Have you guys played with React Native yet?
I haven't. The question was, have I played with React Native yet? I've not. I would love to though.
Do we know what it is?
It's native bindings for mobile, right?
Yeah. So it's running Node on a mobile device, writing all of your application logic in JavaScript or however you want to. And when you're rendering the UI, you are not rendering a web page, but React is being interpreted and native UI elements are rendered to the page. It also facilitates hot code reloading. That's something that is not part of React Native right now, but people in the community are working on it. Or it could be done now.
Yeah, it was in, I think, 22.
Is that included?
Yeah.
Oh, sweet. But yeah, so that means that you don't have to have somebody download a new version of your app. You can push up bundled JavaScript to all the clients, and they get updated logic and UI.
And the way that both the Apple Store and mostly the Apple Store, but the Google Store as well, but especially the Apple Store. When you do, they're called asset updates. So JavaScript files and such are considered application assets. So like in the same category as images, those don't actually have to go through the entire store approval process.
Which is like a 2-week process.
Yeah, it takes ages.
Horrible.
Which is absolutely not the thing you want if you've got a security bug. If you've got a hole in your security, in your app security, you totally cannot wait 2 weeks while it goes through the process. There's another really interesting project that I've been kind of keeping an eye on. It's called NativeScript.
Yeah.
Which the way it works is it actually it uses the native JavaScript bridge that Android devices have. I think it's called the JavaScript bridge, or maybe that's what the Apple thing. Basically, there's a JavaScript native thing that new iOS devices have, and Android devices have had them for ages. But most importantly, they've gotten fast enough now that you can actually start doing stuff with JavaScript, and it interfaces to the C# or Java stuff that's running like close to the heart of the device. So if you really like JavaScript, which I can't imagine why you'd be at a JavaScript meetup if you didn't, I can see a future very soon when you are either writing JavaScript code or something that compiles to JavaScript code on every device. There's JavaScript in space now. I retweeted something that Brendan Ike retweeted from somebody else. NASA's actually using Node to send data, to collect data and send it from spacesuits. So JavaScript is in space. I'm sure it was in space before, but now it's in space for reals. All right. Thank you all very much. It's worth noting that you guys are my first audience. I've never given a technical talk before. So
You did great.
Good job. Thank you.
Nice choice of shirts too.
yeah, thank you. Actually, fun. Alex made fun of me, but this picture of me here.
I was gonna ask.
It's actually the same shirt and the same sunglasses.
I convinced him not to wear the sunglasses.
Yeah, I thought it would be funny if I was wearing the sunglasses at least as long until we got to this slide. But you know, thankfully, calmer minds prevail. Cooler minds.
Cool.
All right.